All right, welcome back. So we've been looking at linear inequalities and how it's kind of cool that we graph a line and it's either dotted if it's less than or greater, something like this. Then I get a dotted line, and if I have, I end up with shading, either if it's greater than, it's going to be shaded on this side, and if y is less than, then it's shaded under my line. And I get a solid line and a solid graph when I have something like y is greater than, less than or equal to, or greater than or equal to. So as long as I have this equal to, I have a solid line. If I don't have an equals to over here, it has to be dashed because none of the points on this line are going to be true. Now again, if y is less than or equal to x, then I end up shading the area underneath my line. And if y is greater than or equal to x, I shade everything above my line. So tonight we're going to be looking at a system of linear inequalities. And a system of linear inequalities is two or more linear inequalities that together, so you could have two, you could have three, you could have five, that together end up forming a system of linear inequalities. Let's look at what that looks like. You need to write down this definition. Pause me if you need to. All right, let's look at what this means. So if I have a system of linear inequalities, something like this, where I've got two different equations going on. Here I have these two guys. And notice here that my x is in pink. And so x would... All right, let's look at this over here. I have a system of linear inequalities and it's color-coded. So I have this x is greater than 3 or equal to. Because it's equal to, I had the solid line. Because it's greater than, it means everything to the right of that x value is shaded. Then I've got this blue equation with y as being less than or equal, not equal, y is less than -2. So that means when x is 0, y is -2. When x is -2, y is still -2. When x is +2, y is still -2, and so on. So it's a horizontal line, but it's dashed because I don't have an equals to. All right, so now I need to look at where these two intersect. How do I find solutions for both? Well, let's shade my blue. I've shaded my pink, so it was everything to the right. My blue gets shaded, and it's everything underneath that's less than -2. Then I need to find where my areas end up overlapping. Hopefully you see here that where pink and blue overlap is purple. So anything in the purple area is going to be a solution to both inequalities. I have to find solutions that will solve both. So let's look at this point right here. This is the point 4, -4. X is 4, y is -4. And I'm going to check that against my inequalities and make sure this is true for both. So y is -4. So let's look at my y equation. Y is less than -2. If I plug -4 in for y, is it true that -4 is less than -2? Yes, indeed it is. All right, so far we're good. Let's look at the x value. My x value is 4. My x equation was x is greater than or equal to 3. I'm going to plug 4 in for my x, and I'm going to get 4 is greater than 3. Is that true? Yes, indeed. So that just confirms that this purple area, the area where they both overlap, is indeed my solution. Again, I color-coded my pink, I did my blue, and then I found where they overlapped, and anything in that purple area where the two overlap is going to work for both of these equations. This is a solution. Now let's come down here and look at how we can look at describing all of the points on a quadrant with a system of inequalities. Notice in the pink area, x has to be positive and y has to be positive. This could be represented as x is greater than 0 and y is also greater than 0. All right, let's look over at my green section. Over here, again, x is positive, but y is negative. So x is greater than 0 or y is less than 0. All right, let's look over here in the purple section. Notice that both of these are systems of inequalities because they both have to be true, both the x and the y. All right, in the purple section, I have a -x and a positive y value for any point in this purple quadrant. So negative x and a positive y means that x is less than 0 and y is also greater than 0. Let's come over here and look at my yellow section. Notice down here, my x is negative, it's still going to the left. My y is going down, so my y is also negative. So any point in this yellow quadrant, I have x has to be less than 0 and y has to be less than 0. They both have to be true. It's a negative x and a negative y. So what this tells me, let's go back and let's look more closely at what this definition states. A solution of a system of linear inequalities is the values that make each inequality in the system true. When you have inequalities, you're going to have more than one solution. It's going to be a whole bunch. Just back up here in this purple area, the shaded section showed all of the possible combinations of solutions. When you have a system of linear inequalities, you're going to have more than one solution. There's going to be more than one set of values that works for both equations. And your graph is going to show you that by the areas where they overlap. All right, let's look at how I'm going to solve by graphing. Let's say I'm given a set of linear inequalities, like y is less than 2x minus 5. And let's make this one our blue. And then let's look at making 3x plus 4y minus 12 our pink. Well, before I can graph anything, I have to get both equations into this y equals mx plus b format. Step number 1. So I'm going to have to do some rearranging here. Let's look at our pink one. I've got this 3x plus 4y is less than 12. So I need to solve for y. So I'm going to subtract 3x from both sides. I'm going to end up with 4y is less than 12 minus 3x. I'm going to have to divide everything by 4. Okay, so my 4's cross out. That leaves me y is less than 3 minus 3x. All right, let's rearrange this. So it's an mx plus b. Y is negative 3x plus 3. All I did was the old swapperoo. I brought this guy forward, and I took this guy, which is positive, and moved him that away. So this is what I end up with. Now I have something I can graph. So let's look at graphing this. Negative 3x plus 3. So this is my b. It's my y-intercept. I'm going to start there. And I'm going to go 1, 2, 3 down and over 1 to the right. And I'm going to do it again. 1, 2, 3 down and 1 to the right. All right, and this is going to give me a line that kind of looks like this. All right, now we need to look back over here. Y is less than. So y is less than has to be over in this area where y is to the left. And let's just confirm that by picking a point. So what have I done so far? I got both equations into y equals mx plus b. The next thing I wanted to do was I needed to actually graph my line. And then once I graph my line, I need to check whether it's dotted or solid. It's going to be one or the other. Remember that this is less than or greater than, and this is greater than and equal to or less than and equal to. And then the fourth thing I'm going to do is I need to shade and check. And then repeat for the other line. All right, let's see if we've done all of these steps. Number 2, I graphed my line. Yes, I did. Number 3, did I check whether it was dashed or solid? Oh, I didn't check that. Let's go back and see. Well, y was less than, not equal to. So I'm going to just take an eraser here. And let's just erase and make little dashes. All right, so this just lets me know that these points that I plotted right here are not actually going to end up working. Let's see how this works. This place right here was 2 and negative 3. So if I plug that into my inequality for 2 and negative 3, let's see if this works. Y is less than negative 3 times 2 plus 3, and my y value was positive 2. Is this going to work? Well, I know that 2 is less than negative 6 plus 3. So this is asking me if 2 could possibly be less than negative 3. Is 2 ever less than negative 3? No. So because this point doesn't work, I know that this is a dashed line because everything up to these points work. Let's test that with finding. So I've shaded, and I now need to check whether or not these solutions work. Let's find any point in my shaded area. I'm going to pick this point right here at -1 and +2. It's well into my shaded area. Does this work? Well, this is saying when x is -1, that y is +2. So let's plug this in. So I plugged my -1 in for x, and I plugged my +2 in for y, and this is +3 plus 3, and this is 2. Is it true that 2 is less than 6? Yes, it is, which tells me that I'm right in the direction that I shaded. All right, let's repeat for the next inequality. So I said we were going to make this guy blue. So y is greater than 2x minus 5. So the first thing is to graph my line. It's already in this equation. We're good. So I'm going to graph y is greater than 2x minus 5. Start at -5 down here. Ooh. And we're going to go up 2 and over 2. We're going to go up 2 and over 2 and up 2 and over 2. And I kind of get a line that looks like this. Hopefully it was up 2 over 1. Don't listen to me. Just do what I do. Okay, so then I'm going to shade under this area. I'm going to shade everything to the right because it's y is greater than 2x. And let's see what we end up with here. Did I do my shading in the right direction? Well, before I can even check my shading, let's check my line and see if it should be dotted or solid. There's no equals up here. It's just greater than. So I need to take my eraser again and go back and create some nice little dashes. All right, I've got a dash line. We're good. Let's go back and let's check and see if I shaded in the right direction. All right, I shaded over here. So let's pick a point over here. This is x is 4 and y is -2. And so is it true in the equation y is greater than 2x minus 5, is it true that 2 times 4 minus 5 is less than the y value? I just plugged this in and plugged that in. And -2 is greater than 8 minus 5, which tells me that -2 is greater than 3. Is that right? Oh no, I shaded on the wrong side. You were probably already saying, Miss Sackno, you're not doing this right. But this is a good example of how shading and checking works. So we're going to erase this blue area that I've shaded over here. All right, that did not work the way I wanted it to. So we're going to take our blue and we're going to shade on the other side of my blue line. And I'm going to get something that looks like this. Probably going to need to draw this line all the way through my graph, so I can shade everything that's included. Okay, got a big blue area. Let's just double check. Let's find a point. Let's find this point right here. Did I shade in the right direction? Is it true? This is x is 2 and y is +3. If I plug this in, 2 times 2 is 4, minus 5 is -1, and y is 3. Is 3 greater than -1? Yes, it is. This direction works. All right, but let's see now if this point also works in my pink. Well, if I even just go back to my basic equation here, is it true that 3 times 2 plus 4 times 3 is less than 12? Well, 3 times 2 is 6. And I am going to add 4 times 3, which is 12. And 6 plus 12 is 18. 18 is not less than 12. Oh no, so this point works for my blue equation, but it doesn't work for my red. So what I want you to see here is that this purple area, the area where my blue and my pink overlap. So it's everything that works for both. So find that pink line, and find that blue line, and find where they're overlapping right here. It's this area in my graph, just to make it a little more clear. It's the pink and the blue. Notice it's not this area and it's not this area. It's this area that's kind of bounded off here by both my pink and my blue lines. Let's find a really easy point. Let's say -2 and 0, and let's check this in both equations. Here, -2 is my x, 0 is my y. Let's just plug it into my first one right here. Is it true that -4 minus 5, -9 is less than 0? Yes, it is. It works. What if I plug 3 times -2 in? I get -6. And -6 plus, well, 0, because my y is 0. Is -6 less than 12? Yes, it is. So the purple area ends up working for both equations. And I could find any point in here. That would work for all of these points. Any of these would be a solution to this system of inequalities. Your turn. Let's have you solve this. I would like you to solve both this system by graphing, going through the same 5 steps that I did with mine. You're solving the system. Make sure that you have this copied down correctly. Y is greater than or equal to -x plus 2, or 2x plus 4y is less than 4. And we're solving to figure out what set of solutions would work for both of these. All right, I'm looking forward to seeing your answers in class tomorrow. All right, let's say that you're asked to write an equality from a graph. You're given the graph. Okay, well, let's just look at trying to evaluate what the equations are first. So first, let's write an equation for each line. And we're going to write an equation. We're just going to keep it really simple. Y equals mx plus b, okay? It's probably our easiest one to work with. So if I'm starting with that, let's look at our blue. And right here, if I'm looking at this line, where does it intersect? It intersects right here. So I know that my b equals 3. And now let's find its slope. To find the next point, I want to find a point that's going to be really clearly on a point, like here or here or here. Okay, so it's really clearly at a place where I have an intersection. I'm not going to choose this. I'm not going to choose something like right here because it doesn't have points. Okay, so to get from my intersection point, I'm going to go down 1 and over 1, 2, 3. So I went down 1 and to the right 3. So remember that my slope is my change in what? Well, it's rise, so it's change in y over my run, or my change in x. So here, my slope was a -1 over +3, or simply -1/3. And my b was a +3. So to put this all in, y equals -1/3 x plus b. All right, let's do the same thing over here for my red. My red is a dashed line, so we're going to keep that in mind but come back to it. For now, let's treat it like a line. Let's find our y-intercept first. So my y-intercept is right here. It's at -2. So that's my b because it's my y-intercept. And I want to find another point that's really clearly at a place where they intercept. This one's going to be really simple for us because there's a lot of really easy points. So I'm going to choose this one right here. Okay, so in order to get from my intersection point there, I'm going to go up 1 and over 1, plus 1 and to the right 1. So my m, again, is my change in my y over my change in my x, or here it's a plus 1 over a plus 1, which is simply an m equals 1. Ooh, I like this. My b, remember, was a -2. So if I'm plugging this in, y equals 1x plus a -2. Let's simplify. Y simply equals x minus 2. Okay, I have equations. The second step that I'm going to want to do is, once I've got that equation down, I now need to go back and figure out what my inequality is. Inequality, and then substitute that for equals. What that means. All right, so this inequality here. Let's look at my pink one first. My pink one's a dashed line. So I know that it's going to have an equal sign. So there's going to be an equals x minus 2. But is y going to be greater or less than? Well, notice that it's everything to the right. And we know that everything to the right, to the left or above my line, if it's above my y equals line, it's going to be greater. Let's test this theory. Let's find a point in my pink. I like this one right here. 2, and 4. And let's try this. Let's plug this in and see if that's the right direction. So when we are writing our inequalities, we're going to check the direction by plugging in a point. We're going to call this step 3. Okay, so for this point right here, 4 is greater than or equal to 2 minus 2. Is it true that 4 is greater than or equal to 0? Why, yes it is. 4 is greater than 0. I've shaded the right direction, so yes, y is greater than or equal to. But it's dotted. Was a dotted equal to? No, a dotted was not. Good catch. Y is simply greater than. All right, and the way I could test that would be to find any point along this line, like 5 and 3, and ask myself that negative 3 is greater than positive 3? Oh, no, it's not. Okay, so this point does not work for my equation, but I bet you this one will. So it's not an equals because it's a dotted line and because the points on my line don't work for my inequality. All right, so I've written 1. 1 is right here. This is part of my system. Y is greater than x minus 2. Okay, let's look at writing my B. Let's shift our focus to my blue. Let's notice when we're writing an inequality where it's shaded. So it's shaded underneath this blue line. It's not shaded up here. It's under. If it's underneath, what do you think it is? Well, if it's underneath, it's probably a less than scenario. So I think this is y is less than negative 1/3 x plus b. Oop, plus 3. Let's check this. In order to check this, I'm going to find any point that's blue. My origin's blue, and that's a really easy point. So I'm just going to check. Is it true that 0 is less than negative 1/3 times 0 plus 3? Well, 0 is less than, 0 plus 3. Is 0 less than 3? Yes, it is. So right here, this point works, which means I have shaded in the right direction, so this is my second inequality. And hopefully what you notice is that my solutions that would work for both of these would be this area right here where both my pink and my blue are shaded. But all I simply wanted you to do when given this picture was to write inequalities from a graph. I did it by writing an equation for the line y equals mx plus b, by finding my y-intercept first, and then finding my slope. The next thing I did was to rewrite the equation as an inequality by noticing whether I shaded above or below my graph. And then I checked the direction by plugging in a point in the shaded area and double checking that that indeed worked. Make sure that you check whether your line is dashed or not to determine whether or not it's an equal to or simply a less than or greater than. Let's see if you can do one on your own. All right, your turn. I want you to write a system of inequalities for these graphs. You have A and B. Go back through what we did. Double check. Remember, you might want to go back and review your notes. If you have a horizontal line, is that a y equals or an x equals scenario? What if I have a vertical line? Y equals or x equals? All right, write your system of inequalities for this. Maybe go back and rewind the video and see what you can do with this.